And here we are at part 6, page 296 of muscle physiology, and we're looking at some more of these graphs. And this is actually a 3-part graph right here. Let's take a look. Stimulus to the nerve is represented here. Notice along the same x-axis, we also have a higher x-axis here, which is called threshold stimulus, and is letting us know that it's a certain voltage is required, which is not surprising because we're dealing with action potentials, and we're going to learn later in neurons, in the stimulus of neurons, that we require a threshold stimulus in order to get the nerve to work, the neuron, I should say, and the muscle cell also is in the same category. We require a threshold. So we might send out a certain, how shall I say, stimulus, and it reaches a certain number. And take a look at this here. Here's the muscle, and here are the various motor units. And here, notice that at this level, nobody is actually depolarizing. Over here, still nothing. Over here, a couple little depolarizations, and we're starting to get maybe just a little bit of tension, more and more and more. Finally, we get the entire muscle at a certain voltage level. Anything above that doesn't do a lot more for us. Once you get the max, you get the max. Okay, so that's the idea here. Sometimes when you're seeing somebody carrying a very heavy package over a distance, and then suddenly they start to shake as they get near the end of their trip, and they have to set the package down. Otherwise, they're going to drop it. And when you're seeing them shake, you're actually watching their muscles switch from one group of motor units to another group of motor units. So usually it's more in this range or this range where you see somebody with an object and they start to shake. As we come down here, you'll notice that the actual tension, there might not be any tension or very little at this point. Okay, so just a little bit, a little more, a little more, a little more. Here we have the maximum because all the motor units are being used. So that's all you get. There's also a recruitment order that goes from the smallest of the fibers to the medium size to the large fibers. Right. Finally, the large fibers get recruited at the very end. Okay, and so when you start to get out to the large fibers, you're also getting out, in some cases, to the least aerobic. So you begin with your aerobic fibers, and you end up with your least aerobic. And so when you get out to that level, you don't really have much time at that point, because anaerobic, the anaerobic fibers are the ones that have the least amount of endurance. Alrighty then, let's take a look then at over here. We have a type of muscle contraction where we're applying force, and the crossheads, the myosin crossheads, connect up and they move, and we lift a weight, and there is a change from origin to insertion. Here, there is a change, and the object moves, and that's referred to then as the isotonic contraction. Okay, and we compare that to what is referred to as the isometric contraction. Here again, we're applying a force. In this case, we have a heavier weight. If we try to apply 3 kilograms of force, we don't move the 6 kilogram weight, and nothing happens over here. Nevertheless, we have cross bridging. We nevertheless take up slack in the connective tissue, but we don't actually have the generation of tension that would be enough to move the object. Instead, we have generation of tension, which is just going to maintain a certain pressure, but not movement. And so they go through a little bit of explanation here in the text of what's going on with Isotonic. They're going to talk about isotonic and isometric here. And it says here that the isotonic contraction actually comes in what they say is two flavors. Okay, Dr. Merib is very, how shall I say, expressive in her way. One is referred to as concentric contractions, and those are the contractions that actually do work. They create a contraction situation, they perform a force, and the muscle shortens as the work is being done. Okay, then we have something that's referred to as eccentric contractions. Okay, and I'm sorry about the glare. Let's get rid of that. Okay, so eccentric contractions in which the muscle generates force as it lengthens. Okay, so don't let this hurt your mind. If it's confusing, read more about it at PubMed Central or someplace. But I'll never test you on this. So, but it is an interesting idea, and the idea is expressed especially if you're considering calf muscles and you're walking or running uphill. About 50%, it says here, of the forces involve sort of equally divided between concentric and eccentric. And the idea is that as you're moving through your motion to walk uphill or run uphill, some of the muscle is lengthening as you're applying force. Okay, now it says here also that it's the eccentric types of contractions that contribute to soreness. So that's something to consider here. They don't really know why. They suspect micro tears in the tissue. They talk about that here, that muscle stretching might occur as you are applying force to a lengthening muscle, which results in then micro tears. But that's only a guess. It's not something that has been established one way or the other. Why do we have isometric contraction? What does it do for us? Basically, it's stabilizing joints. As you stand in line, you're stabilizing the joints as you maintain your posture. Another good example, though, would also be raising your arm. Maybe there are some things for you to operate at a level above your head. It could be just, cleaning a shelf that's higher than your head. And so you raise your shoulder and you stabilize your hands at a particular height, and you move things around on a shelf or clean it or whatever. There might also be some operation that you need to do at that higher level, spinning dials or doing some sort of activity that is requires you to put your hands above your head to do something that involves manipulation. And so your shoulder is holding your hands at that height. Okay? So stabilizing joints is the purpose of isometric contraction. Of course, you can just put your fingers underneath a countertop in which the counter is actually bolted to the floor, and you'll get your exercise that way by doing isometric contractions. So that's a way of strengthening a muscle. Okay, moving right along, then we have the idea of what's happening not only when the muscle is active, but when it's relaxed. So even relaxed muscles are almost always slightly contracted. Okay, and some people are a little overamped, and they're on the edge of cramping and stuff like that, so they need to rub the muscles to increase circulation. But the idea here is that we're in daytime. So anytime we're in the daytime, or I should say wakeful state, we have what I call daytime cocktail, which includes epinephrine. Epinephrine is a part of the sympathetic tone that happens when you wake up from sleep, and then when you go to sleep, you switch over from sympathetic tone to parasympathetic tone. So we haven't yet dealt with that idea, but there are actually separate hormonal cocktails for each. So by day we have epinephrine. We have epinephrine that can elevate the thyroxine, and we have insulin. By night we have no epinephrine. Okay, And we have some thyroxine, but it's greatly reduced. And we have growth hormone and growth factors and that sort of thing at night. So completely different thing going on between sympathetic tone by day, parasympathetic tone by night.